All right, good morning everyone. Welcome back. So today we're going to go ahead and get our hands dirty in the Apex Wilderness. So this should be a fun day. But before we get our hands dirty, we have to also have a way to wash them to make them clean again. And we have to be able to work clean. And so we'll do that through version control and through creating a Git repo. I think it's probably familiar for some of you, but if it's not, it's very easy to do. So what we'll do is we'll open up our terminal, and then you would just do git init. As long as you're in the root of your project folder, you can initialize a Git repository, and we'll just do a local Git for now. It's up to you, of course, if you want to go ahead and set up a GitHub page. It can be cool because then you can see, what you've done throughout the year, and you can kind of get credit for all the commits you make. But it's not necessary. So at least initialize the Git repo. And then once you've done that, you can use GitHub Desktop. And if you're not familiar with Git that much, I'll show you the real basics of using it. We won't get into the details. We don't need to get into many details. We're really just using Git so that we can control our process. It's very important in the refactoring process because as you begin, improving the quality of your code base, you have to be very systematic. So we're going to learn a very systematic way to improve the quality of our code base, and that kind of requires a lot of restraint. Because when you start cleaning things, you find messes, and then you want to clean those messes. Another way I've heard it said is that you start digging, and as you dig and you dig, you eventually dig yourself into a hole you can't get out of. So version control is a really good way to protect ourselves because sometimes we're going to make changes that are wrong. That's just kind of how it goes sometimes. So if you have a backup, if you have your version control and you get yourself into a hole that you're in trouble with, you can always revert and then get back to a place that you're kind of comfortable where tests are working, where the code's working, and you can start back over. So all you really need to do is whenever you can install GitHub Desktop, and then you'll find whenever you have a repo, you can add one. You'll add an existing repository. And then when you do that, just choose the local path of your particular project. I keep everything in a developer folder, and then I have the different languages, and then I'll have this in my Salesforce folder. So once you do that, you'll open it up and you'll have, a bunch of changes you can see that we made last time because we installed the package, we pulled down the metadata, and now we have all these changes. And so all we really need to do now is we're just going to say init. And hopefully I spelled it right because I can't see it because I'm blocking my view. So I'm going to init. And that's great, easy peasy, right? If you did want to connect it to your GitHub repo, that's very easy to do as well. You can, come in and let's see, how do we do that? I think there's a do. Maybe because I've already done it, it's already connected. I think that whenever you haven't done it yet, you'll be prompted. It's very easy. You just connect your Git repo, your GitHub account to GitHub Desktop, and then you can push it. And so what'll happen then is those changes will go into your GitHub account, and then you'll see the change in the repo in the code base. So if you have any questions about it, let me know. My explanation right then was not great, but it's very, very easy, and you probably already know how to do this. All right, so now we're working clean, right? And that's what I was meaning before. Like, I love that. Like, if we go into back into our terminal, when we do git status, we can now see that we're working on a tree. Our tree is clean, and so our hands are kind of clean. And now we can begin to dive in. So what we're going to do in the systematic refactoring process, and I'll talk about this aspect, this understanding of being systematic later on when we talk about some more details. There's more content coming, but for now we're just going to start thinking about how we would clean up individual classes and the connections between them. So, what I would begin with is we can look at our triggers and we can see, wow, this trigger might need to be cleaned up. We'll have a better way to measure it later. I'll talk about how we can figure out, how complex this is and how problematic it is. But for now, we're just going to bypass that and say we want to fix everything. And so we have our trigger and we have our handler, so we can see the different ones. So we're going to look for impacts right now, right? What are the dependencies to my trigger? Because these are going to be in scope. And so I want to understand the current state as well as I can. So I'm going to first begin by understanding the scope. And it's really, really easy, right? I can just come into each reference inside my trigger and I can see where the dependencies are. Easy peasy. There's two dependencies: adventure park trigger handler and service appointment handler. All right. And now we're going to look through these to see, okay, well, what dependencies, if any, do these have? So we'll scroll through and we're just kind of look, it's like pretty easy. You can kind of just look and visualize where these things are. If anyone knows a better way to do it, there's probably a good way. You should just do it by sight. And there you go. There's nothing else here. It's just that particular one. And here we're looking for dependencies. On after insert, and we don't. So everything happens here. I think, but that really doesn't make sense because there is a helper. So am I missing it? Let's see. There we go. So we do have our helper. Okay, and then we have our test. So these are going to be in scope, these 4 files, and we have our test here. So what we want to do first is we want to understand how good is our coverage. So let's go ahead and run our test with coverage, and we're going to see out of these 4 files, how good is our testing? How much coverage does we have? It doesn't actually mean how good it is, it just means how much coverage we have. So our trigger is fully covered, 100%. Our handler, 98. Helper, 100. That's good. And then our service appointment handler, not so good, right? 79 is acceptable, but it's really the bare minimum, which means that there's a lot that's not covered, which means that if there was a change in the code base that had an unintentional impact on this, you may not find it right away because there may not be good enough tests to protect this bit of code against unintentional changes. So the first step we're going to do here is we're going to upgrade our API versions. You don't have to do this. Sometimes you have to be careful because every once in a while there is some version of the code that you're using that isn't compatible with the new API. But for the most part, it's fairly safe. So we're going to change our API version to 65, and we're going to do that for all of these. And then we're going to commit. So this is like the one change we're going to make, and we're going to be very strict with ourselves when we're making changes. We make a change, we test. We make a change, we test. We make a change, we test. And we're very, very careful because if you go too long without testing your code, then when you if you've made a bunch of changes and then you run it and it breaks, then you have a whole big scope of things that are possibly causing your problems. So we're going to control that really well. So we're going to do that. We're going to save it, deploy it to our org, come back to our tests, run these bad boys, and we should be fine. We shall see. Great. Easy peasy, right? Okay. Now let's go ahead and look through our tests because we want to know how good it is or how bad it is. We kind of want to know what it's testing, get a sense of this. And I also will start making changes. So let's talk about the structure of a unit test. Unit testing is extremely important in my mind. Some people don't care about unit testing. Some orgs bypass unit testing. They create fake unit tests to just get code coverage. And in my mind, it seems kind of silly because the unit tests are for us as developers. They're not for code coverage for Salesforce. They're for us to understand the logic of our code. How well do we understand what we're trying to do? How well can we test it? It's very important. So there's a structure for a unit test. Every unit test is composed of three things: the given, when, then, right? Given this set of data, when this event happens, then these are our assertions. So we can kind of structure our thinking. And in the beginning, it might be helpful to put in some comments. I don't usually keep these in there, but if I had a given, it would be, given that a park is inserted. It's actually given that we can create a park. And in this case, we're going to have a when the park is inserted, and then we're going to have then we're going to assert a bunch of things. So we can see that anytime now, that little bit of structure gives us a little bit easier insight into what it is we're trying to accomplish with this test. Creating a park, that's a really bad name. Test creating a park tells us nothing. What are we supposed to understand? Like, at the very least, I guess it's something. We know we're creating a test or a park. We know it's a test because we're in a test class. So I'm very much, I don't see any value in adding the word test pretty much anywhere in a test. You're in a test. Why add test? So these are the kinds of naming things that can make your code a lot stronger and your understanding clearer. Clear names, clear understandings. Creating a park doesn't tell us anything. So we'll look in a little bit about what a better name is. So first we have our given. We create this park. We initialize it, right? And then test. What is that actually? So I always wrap my when inside the test start and stop. In the real world, it's not always so easy because you may come across tests that are overly complex because the code base is overly complicated. And you have to kind of finagle your test start and stop just so that you don't hit governor limits. So it can be very annoying. But in an ideal world, in our goal state, we're going to wrap our when inside our test start and stop. And that makes it even more clear. Now we have like a really strong structure forming. And now we can see all these assertions are happening. So what do we assert? Well, we created a park and it looks like it should have a price book. So we have this custom field called price book that anytime there's a park that's created, it looks like there should be a value that's not null for a price book. That makes sense, right? You have like a new, in this case, what is an adventure park? It's probably some place that people can go to, and maybe they would need to pay money for it. So we want to create some sort of a price book to use with our products and things. When we do that, we should have an account that gets created. So that's interesting. We should have a product that gets created. We should have 2 price book entries that get created, and we should have an asset. So from a perspective of the unit test, this is pretty good because now we can see, oh, okay, so when a park is created, then we need to create a bunch of supporting data as part of our business logic. So that's going to be a much better name for the test, should create supporting records when park is created. Now, when we're long gone and we're on to our next big job, making, $1 million a year, then the next developer that comes along that's looking at our old code base is going to say, should create supporting records when park is created. That reads like English, I know what that's supposed to do. That's supposed to create supporting records. Now, which supporting records? We obviously can't list them all out there, and we don't need to. We just need to look and see, okay, cool. Those are all the things that need to be created. Easy enough. So what we'll expect to find is that we're going to expect to find this kind of logic in our trigger and our helper or handler. we're going to expect to find that thing is happening. And so now that we know that, we have a little bit more insight into what the code is doing that we didn't have when we first started. Great. Okay. So I'm going to go ahead and remove these comments. Feel free to leave them in. I did this in the beginning. I would leave them in just to kind of make my thinking very strong in this regard. One last thing I want to point out because it came to my mind. In this case, I would improve this just a little bit. You know, whenever it's is null and this is not true, the output you get from the, I'll go ahead and show you, you know. So let's say that we're going to change this to is null. So this is going to fail. We're going to run it. And then we're going to look at the output that comes when this fails. All right, we knew that would. We'll go down to it, and then we'll say nullable object asserted with non-null value. That's really not helpful output, right? If we're looking and figuring out why our test failed, this is not helpful. Now, let's, if we were to change that, now let's look, we'll make another one fail. We'll say that we should have 2 accounts. So with r equals, we're going to see what this says. Run this. Oh yeah, sorry. Let's go ahead and comment this out so that we can fail on the second one. Now we have expected to actual 1. That gives us a little bit better understanding. Maybe it's not great, maybe it just depends on the context, but at least we understand what's failing. Well, in the non-nullable, we also understand that. So in my mind, my typical convention, and go with your own, you know, go talk with your team and think about it for yourself and see what you think is going to be best. In my mind, I'll usually not add. I'm very conservative when it comes to adding these kinds of comments. Oops. So you know that you can add a comma. This is an overloaded method, so you can either just pass in what should be not null or is equals, but you can also add a message, and this message will show up down there in the assertion exception. So in this case, Park should have a price book value. So actually, we'll go ahead and set it back to null. We'll look at this again. And then here we go, right? Assertion failed, nullable objects asserted with non-null value. Park should have a price book value. So in this case, this is valuable. You know, it's more valuable to have a little bit of insight into it. But what I think is not valuable is like if I was to say, should have 1, you know, or something like that, that doesn't really have much value. If you should have 1 account, that's a little bit better. So just kind of use your own judgment. These things must provide value. If these messages don't provide value, if you're doing them just because you have to, or you haven't really thought about what is going to be useful to understand whenever this code doesn't work, then it's just kind of a waste of effort in my mind. Okay, cool. So we've made this change. This is working. So what do we do next? Go on to the next method? No, not quite. We commit. So I actually am a bad person. Oh my gosh, no good, right? So what I'm going to do first is I want to go in and uncheck this because I should have gone after my test pass. The next thing we should have done was we should have go ahead and commit. So we're going to say change API version. Commit that. You can do branches and stuff. It doesn't really matter when you're on your personal repo. You don't really need different branches, so I wouldn't really worry about it. Feel free to do whatever you want to, but you know, our goal is really to use version control for its saving grace. so that if we get ourselves in trouble, we can get ourselves out of trouble and we can get back into a clean state that's working again quickly. It's not that we have to, worry too much about version control in and of itself. Okay, so we've committed our API version changes, and now we've cleaned up this this method, this test. So rename test method, and a lot of the commit messages when you're cleaning up code bases are kind of boring and they're not as interesting or useful as other kinds of commit messages. It just depends, but I would say most of the time your commit messages will be a little bit more boring. And so kind of use your own judgment. I don't put a lot of stock into them being perfect because, when you're doing code review for this, you really want to see the output because it's the same behavior, right? We're going to try to make code level changes without changing the behavior of the code. And we'll talk more about that in the future. So some of these messages can be pretty simple. I wouldn't worry too much about it. There we go. I'm going to go ahead and push those to my GitHub account. And I think we're going to go ahead and stop for now because we're going pretty far. And so feel free now. We have one more test method in this adventure park trigger. We'll do this one next time. But I would say go ahead and give it a try. See if you can figure out what's going on. Maybe give it a try to name it, try to format as a unit test, think through the assertions and if they make sense or what they mean, how it could be better. And we will get to it next time. All right, see you there.